Alright, so in this video we're going to talk about the slope-intercept form of a linear equation. So I just did a video on the point-slope form, and now this one's going to talk about another form which is the slope-intercept form. So if we have a line with slope m and y-intercept b, it has the equation y equals mx plus b. Right? One of the most famous equations from algebra. It's something that everybody who goes through a high school algebra class comes out of it knowing y equals mx plus b. Even if they don't know what it means, they still remember y equals mx plus b. So we call this the slope-intercept form of a linear equation because the numbers we plug into this, that the m represents the slope of the line, the b represents the y-intercept, so that's the slope and the intercept. Right? Whereas the other one that I did a video on recently, the point-slope form of a linear equation, the numbers we have in there represent the coordinates of a point on the line and then also the slope of the line. Right? So I just wanted to real quick show you how to change from the point-slope form into the slope-intercept form. So if you haven't seen the video that I did on the point-slope form of a linear equation, which is a form that looks something like this over here, you can check that one out. And here I'm just going to show you how to take it from this form into that slope-intercept, that y equals mx plus b form. Because some problems that you do, like when you solve the problem, and if you watch another video I did, like the examples we did there, where it's easy to write the equation using the point-slope form, but sometimes the problem wants the answer in the slope-intercept form. So sometimes you go through the steps and you get your point-slope form, but then you have to convert it to y equals mx plus b. So I just wanted to take a minute to show you how that works. And there's really just two basic steps, and it's always the same two steps to convert from one form to the other here. All right, so if I have the point-slope form, which if you recall is y minus y1 equals m times x minus x1, all right, so that's what we have here. To convert that into the slope-intercept form, I have to do two things. All right, the first thing I have to do is distribute that slope, that 3, into the parentheses. Right, because basically for the slope-intercept form, I just need to get the y by itself, and I need everything else on the other side of the equation. Right, so I start by distributing that 3, so I have y minus 2 equals 3x minus 12. Right, so I multiply the 3 times x and the 3 times the minus 4. And then, so that's my first step. My second step is to take whatever number's over here with the y, and either add or subtract that to the other side, depending on if it's a plus or a minus here. All right, so since it's a minus 2, I do the opposite of minus 2, which is plus 2. So I end up with y equals 3x minus 10. And now I have this same equation, but in the other form, in the slope-intercept form, which means it has a slope of 3, and this graph is going to have a y-intercept of negative 10. All right, so again, some problems ask you to give your answers in the slope-intercept form, y equals mx plus b. You can still use the point-slope form to get your equation, and then it's just a couple quick algebraic steps to put it into the slope-intercept form from there. So I just wanted to point that out to you so you're aware of how that works. All right, I'm going to pause this here and erase this and then put up a couple examples where we work explicitly with the slope-intercept form. Alright, so we got a couple examples up here. The first one, we're asked to find the equation of a line with slope 3 and y-intercept negative 2. Alright, so if they give me the slope and they give me the y-intercept, well, that's going to be the slope-intercept form. Right? That's why they call it slope-intercept form. So if you have those two numbers, all you have to do is put each one in the proper spot. Right? Remember, the slope is your m and the y-intercept is your b. Right. The other equation that we were just looking at, the point-slope form, m there also represents the slope. Anytime you're talking about a linear equation or a line, that letter m is always going to represent the slope of the line, no matter which form of the equation you're working with. All right. So wherever you see the m, that's going to be your slope. All right. So if my slope, my m is 3, my y-intercept b is negative 2. Well, y equals mx plus b. So I just do y equals m, which is 3x, and then plus b is a negative 2. So y equals 3x minus 2, that's the equation of the line that has slope 3 and y-intercept negative 2. Right? So if they give you the slope, if they give you the y-intercept, all you have to do is plug those numbers in for the m and the b. Just make sure you put the right one in the right spot, and you've got your equation with little other work that you have to do there. Right? And the reason this works, the reason that b there is the y-intercept when you're in this form, remember, when we're talking about the y-intercept of a graph, it's the point where the graph touches the y-axis. Well, at that point where the graph touches the y-axis, the x-coordinate has to be 0, right? Because I'm not moving to the left into the positive x's, I'm not moving to the left, I'm not moving to the right to the positive x's, I'm not moving to the left to the negative x's, I'm right there on the y-axis, which is where x is equal to 0. And if I plug in x equals 0 here, I get 3 times 0 minus 2, which just equals negative 2. Right? So when x is 0, y is negative 2, that gives me the y-intercept of that graph. That's why in this slope-intercept form, the y-intercept is that number at the end, because that's always going to be what you get when you plug in x equals 0, you get your y-intercept. All right, so just kind of pointing that out of why this formula, why that b there is the y-intercept, right? It's because when x equals 0, that's what you get. All right, the next example here, a little bit more complicated. Find the slope and the y-intercept of the line 3y minus 2x equals 0. No, 3y minus 2x equals 1. I should read what's actually up there. All right, so I want to find the slope and the y-intercept of this line. All right, so if you have a linear equation and you're asked to find the slope of that line, or if you're asked to find the y-intercept of that line, well, if I have the equation like this, if I don't know all this other information, if they just tell me y equals 3x minus 2, just by looking at this, I know that the slope equals 3 and the y-intercept equals negative 2, because it's in that slope-intercept form, right? It's in the y equals mx plus b form, so I know the m is my slope, I know the b is my y-intercept. So for any other linear equation that's in a different form, like this one here, 3y minus 2x equals 1, that's not in the y equals mx plus b form, right? But if I can rearrange it and put it in that slope-intercept form, well then that number attached to the x is going to be my slope and that other number is going to be my y-intercept. All right, so anytime, no matter what your linear equation looks like, if you have the equation and you want the slope and or the y-intercept, you just have to put it in this y equals mx plus b form, which basically means getting the y all by itself. So since it's 3y minus 2x equals 1, first thing I'm going to do here is add 2x to the other side. So I'm going to have 3y equals positive 2x plus 1, right? And then to get the y by itself, I have to divide everything by 3. Now when you do this, you have to divide everything by 3, right? All the terms on both sides of the equation get divided by that 3, right? Whatever you do on one side of the equation, you have to do on the other side, but you have to do it to the entire side of the equation, right? So don't just do the 2 divided by 3 here, you also have to do the 1 divided by 3. So what we end up with then is y equals, and then I'm going to have a 2/3 x, and then plus 1/3. Right, so I took this equation, this 3y minus 2x equals 1, and I just converted it into the slope-intercept form. Y equals 2/3 x plus 1/3. Right, so how does that help me find the slope and the y-intercept of the line? Well, the slope is 2/3. Right, the slope is the number that's attached to the x when I'm in the slope-intercept form. The y-intercept is that constant at the end. Right, so my b is equal to 1/3, and there's my answer to the question. Right, so again, for any linear equation, no matter what form they give it to you, if they ask you to find the slope or if they ask you to find the y-intercept, all you have to do is convert it to slope-intercept form, and you got it. Right? A lot of people see something like this where it says find the slope, and they think, oh, I need to use a slope formula, the y2 minus y1 over x2 minus x1. Sometimes to find the slope you have to do that. If you have the coordinates of 2 points on the line, you can use that formula to find the slope. If you already have the equation of the line, it's actually a lot easier to just convert it to slope-intercept form to get your slope, and you also get your y-intercept there as you got it. All right, so that is the slope-intercept form, y equals mx plus b, another important formula for you to know going forward through algebra and precalculus and calculus. It's one of those ones that comes up all the time.